Okay, so in this lesson, we're going to talk about transformations, and basically, we're going to start with the parent function. In this particular lesson, will be x squared, and another lesson we'll look at the absolute value of x, and in another lesson we'll look at the function that's the square root of x. So we're going to look at those three functions, and we're going to graph the transformations of those functions. And so the transformations that we're going to look at in these lessons will be vertical shifting, reflecting about the x-axis, and then horizontal shifting. Now there's also stretching and shrinking, but we're not going to focus on those two in these lessons. It will just be these three lessons. And then in another lesson, we'll look at stretching and shrinking, that kind of transformation. But let's go ahead and graph up the parent function x squared. Now your parent functions are the basic functions, x squared. The other, in the next lesson, it will be f of x equal absolute value of x. That's your parent function. So from this function, you can graph other functions, and then other absolute value functions, rather. And then the other one will be the square root of x. And then from this parent function, you can graph other functions. You can shift to the right, to the left. You can do a vertical shift up and down, a horizontal shift right, left. You could do reflection about the x-axis. You could do stretching, shrinking, and so forth. Okay? But in this lesson, we're going to focus on f of x equal x squared. So what you need to do, remember, is in order to deal with drawing transformations or graphing using transformations, you need to know what the basic graph looks like. So for f of x equal x squared. So we're going to use a t-table, and you're just going to plot about 5 points or so, and then from that parent function, you can graph all these other transformations, just knowing what this looks like, and you can graph the others. Okay. All right. So it's gonna be very simple. Okay. So you first of all need to know these basic points for x squared. So if x is 0, I get, remember, fx anything is y, so I get y equals 0 squared, which is 0. If x is 1, I get y equals 1 squared, which is 1. If x is negative 1, I get y equals negative 1 squared, which is positive 1. If x is 2, I get y equals 2 squared, which is 4. And if x is negative 2, I get y equals negative 2 squared, which is also 4. Okay? All right, so those are the 5 that you're going to use on your parent function, and then from those 5, you can transform the other functions. You can use transformations to graph other functions of x squared. Okay? All right, so let's go ahead and graph this first. So I'm going to graph this. I'm going to use a transparency here so I can move stuff around. Okay, so let's see. All right, so we're going to graph 0, 0. All right, so let's say 0, 0 is here, the origin. And remember the other point, if you go back and look at the other point was 1, 1, negative 1, 1, 2, 4, and negative 2, 4. So we're going to graph those points. So 1, 1, 2, 4, negative 1, 1, and negative 2, 4. Okay? And so I'm going to connect. We're going to connect these with a curve. Do the best you can. Something like this. Alright. And that is, this right here, is f of x equal x squared. So that's f of x equal x squared. Okay? Alright, now, let's see what happens. I'm going to root this now. So that's what x squared looks like. It's a parabola. Fx equals x squared is called the parent function. And you're going to see that you can graph transformations of the quadratic function, the parent function. Now remember, these are the 5 points. You use 0, 0, 1, 1, negative 1, 1, 2, 4, negative 2, 4. And remember, let's talk about symmetry again. So remember, this quadratic function is an even function. It's even because it's symmetric about the y-axis. So when I reflect this point about the y-axis, I get that point. When I reflect that point about the y-axis, I get that point. Okay? Or any point reflected, I get the other point on that graph. Also, if I fold the right side about the y-axis, I get this side. Okay? All right, so let me remove this, and then let's graph f of x equal x squared plus 5. So let's see what happens when I graph x squared plus 5. Now, remember what this means. Okay, so let's look at this in terms of a t-table, or partially a t-table. So I want you to think about this. If x is 0, okay, if x is 0, if I cover this up right now, and I'm just looking at the parent function x squared. If x is 0, I get 0 squared, which is 0. Okay, and so that will be my y value, just like this was. But then I want to add 5 to that. So what does that do to this y value? Well, it adds 5. Okay, so when it was originally, I want you to notice this. See, when this point was originally the origin, the new transformations becomes 0, 5. So notice the x coordinates stay the same, but the y coordinate increased by 5. So let's look at this one. I want you to think carefully what's happening. When x is 1, look at this for right now. That's 1 squared, which is 1. Okay? That point right here is the same as this point. But my new transformation says I want to add 5 to this, so I'm increasing the y value by 5. So in each case, I'm increasing the y value by 5. The x coordinates are staying the same, but I'm increasing the y value by 5. So what do you think is happening when I'm increasing the y value by 5? So remember, I want you to think about this. For the parent function 0, 0, the new function, and when I say new function, I mean x squared plus 5, I'm increasing the y value by 5, which means that it's no longer 0, 0, but it's 0, 5. And notice what happened to the graph. What did that plus 5 do to the graph? Well, that plus 5 shifted the graph of x squared up 5 units. That's what it did. So x squared, okay, see right here? Remember the point? So this point becomes 1, 6. I want you to see this. So think 0, 5, 1, 6. So here's 0, 5. Right here. See this? 0, 5, and here's 1, 6. So my parent function was here for x squared plus 6. What did I do to this parent function? I shifted it up 5 units. So every point on that graph, look what's happening. Every point on that graph is being shifted up 5 units. That's what's happening. Okay? So this right here is f of x equal x squared. All right? Then I'm going to go ahead and do this. Then okay. Then that's this. Then the new graph will be shifted up 6 units. So looks what's going to happen. So now you're not going to have access to transparencies like this. So on your graph paper, you're going to do this. All right. So here are my points. Okay. Here are my points. This was the parent function. This parent function. It keeps moving. All right. And then here's a new one. So every point. So remember, I want to graph this. Let me go ahead and do that here. So I want to graph f of x equal x squared plus 5 this time. Okay? So x squared plus 5. So what do I need to do to the parent function to get this graph? Well, I've got to shift all these points up 5 units. So this point shifted up 5 units. 1, 2, 3, 4, 5. This point shifted up 5 units. 1, 2, 3, 4, 5. This point shifted up 5 units. 1, 2, 3, 4, 5. This point right here shifted up 5 units. 1, 2, 3, 4, 5. And this point here shifted up 5 units. 1, 2, 3, 4, 5. And so my function x squared plus 5 looks like this now. Okay? And so here's the idea. When you graph these by transformations, you're going to graph the parent function. You must graph the parent function first. And then if you're adding 5 or subtracting 5 or so on, that's called a vertical shift. So a vertical shift. So you're going to show the vertical shift. And remember, all I did was I picked those 5 points. Do you remember those 5 points? And I just counted. 1, 2, 3, 4, 5, put a point. 1, 2, 3, 4, 5, put a point. 1, 2, 3, 4, 5, put a point, and so on. And then I connected the function. All right, so notice again. All right, so remember, right here, this will be the parent function, right? I'm moving it up 5 units. And this is now, the red is now x squared plus 5. All right, so parent function, they should be identical. All right, moving it up 5 units. Moving the parent function up 5 units, I get the red graph. Okay? Alright, so that is called, right here, when you shift up or shift down, that's called a vertical shift. Just vertical shifting. And it's going to look like this. See where you had x squared plus 5? That meant I take the parent function x squared and I shift it up 5 units. Okay? If this were, let's say I want to graph f of x equal x squared minus 5. Let's say I want to do that. So going back to this again, all right, so remember you're going to graph the parent function first. So what's the parent function here? The parent function, so first you're going to graph the parent function. Alright, so you're going to graph the parent function using those 5 points. And then what you're going to do now is you're going to shift it, all these points you're going to shift down 5 units this time. Okay, you're going to shift down 5 units. Alright, so basically you're going to get this. You're going to get, let's see, so you're going to get this time. Alright, so remember, this is my parent function. Okay, this is x squared. Make sure you see that. And so from here, what do I do this point? How do I, remember I want to graph this. I want to graph f of x equal x squared minus 5 this time. Oops, went off the page. F of x equal x squared minus 5. Okay, can't see it, but that's f of x equal x squared minus 5. So this point, you're going to go what? Remember, this is a vertical shift, so if you take your parent function, see right here, if you take your parent function and you subtract 5 from it, that's a vertical shift, but you're going down. So you're shifting down 5 units, okay? Alright, so 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. And then you just draw your parabola. Draw your parabola and you're done. That's all this is. Okay? And that's it. So this right here, the green is f of x equal x squared minus 5. Alright, so in general, here's what's happening. Okay, so here's what's happening. Let me put that here. Okay, so in your handout, okay, remember we're talking about vertical shifts. So in your handout, if you take your function, in this case it was x squared, and add c to it, add a number, you're going to shift it c units vertically up. Okay? If you subtract c, then you're going to shift it c units vertically down. So you're going to go down c units. Okay? So for a vertical shift, see how it's on the outside? If you're adding, you go up. You take your parent function, you go up. If you're subtracting, you're going to take your function f of x and you're going to go down that many units. Okay? See how it looks? So this is f of x plus c, you go up c units. Subtract c, you go down c units. Okay? Alright, so that's vertical shifting. Alright, now remember, this is how you're going to do this on a worksheet. So listen, this is how you can do this. So let's suppose it says this. Let's suppose the direction says use the graph of f of x equal x squared to obtain the graph of, let's say it's g of x equal x squared minus 7. Okay? Alright, so you're going to graph f of x and you're going to graph g of x. Now remember, f of x equal x squared, that's your parent function. You're going to take that parent function, you're going to do a transformation to it to get this function. Now you need to recognize what kind of transformation is it. And you're only talking about 3 transformations in these lessons. Vertical shift, reflection about the x-axis, and horizontal shift. All we've done so far is talk about a vertical shift. So do you see that this is a vertical shift? So you're taking your parent function and you're shifting it down 7 units. That's all you're doing. All right, but this is how it's going to look on your worksheet or a test. So here's what you're going to do. You're going to grab the parent function first. Okay, so grab the parent function. So remember, your parent function is 0, 0. Your points, your 5 points, 0, 0, 1, 1, 2, 4. Negative 1, 1, negative 2, 4. Okay, and then you draw your graph, just like this. That's all you do. Okay, your points that we used. Okay, now, remember, this is f of x equal x squared. Now what you want to do is you want to graph f of, g of x, which is x squared minus 7. So you want to graph g of x this time. So here's your function f of x, that's going to be your parent function. And since I want to graph, this is going to be the green one, since we want to graph g of x equal x squared minus 7, that means that from a parent function, I'm going to shift down 7 units. So every point's going down 7 units. 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7. And then you just graph it. Do the best you can with this. Something like this. And there's your transformation. So this is, so all I did, I used transformation. So I graphed the parent function, and this subtract 7 means I go down 7 units. So I took every point and I went down 7 units. And that's what you show. That's all you do. Alright? So just notice though, you're going to graph the parent function first, and then you're going to do the transformation. Okay? Alright, so that's that one. Alright, now let's look at what a reflection about the x-axis looks like. Okay, so it's going to be this kind of situation. All right, so the next one's going to be reflection about the x-axis. Okay, now we are still talking about the parent function x squared. Okay, so this lesson is only dealing with x squared, with the quadratic. Alright, so remember what that looked like. That was this function here. So this is Still using the same parent function, okay? This is still the same one right here. Okay, now this time though, I want to talk about, well, what happens when reflected about the x-axis. See, this is my parent function. I want to reflect it about the x-axis right here. Okay, so again, parent function, you want to reflect it about the x-axis. Alright, so basically it look like this. Watch. Let me just take the green one. So here's my parent function. And we're reflected about the x-axis. I get this function. See this? So this piece reflected about the x-axis. I get that piece. This piece here reflected about the x-axis. I get that piece. You see that? So this piece becomes this piece. This piece reflected about the x-axis becomes that piece. All right. Now let's see what that looks like. So if this is x, if this is f of x equal x squared, that's my parent function. What does this function look like? Okay, so let's look at this. Notice right here, you see these 2 points right here? When I reflected, the x coordinates stayed the same. What changed? Well, the y coordinate changed. They're just opposite. See how this is a positive 1 and this is a negative 1? You see how this is a positive 4 and this becomes a negative 4? The x coordinates stay the same. It's the y coordinates that change. So basically they become opposites. The y coordinates became opposites. Now remember, f of x is y. So this x squared is my y value. So if we make it opposite, I put a negative out in front. So in other words, we're going to graph this. Watch what we're going to graph. We're going to graph this. Okay, graph g of x, let's say, which equals negative x squared. That is a reflection about the x-axis. See that negative out in front? So that says I take my function x squared and I reflect it about the x-axis. So this is a reflection about the x-axis. That's what that is. So again, if you think about it, here's my parent function. Here's my x squared. 0, 0, 1, 1, negative 1, 1, 2, 4, negative 2, 4. And I reflect it about the, so I take this, and I reflect it about the x-axis, I get that. Okay, so that's going to become, this right here is going to become g of x, which equals negative x squared. Alright, so if you think about it, here's what's happening. If x is 0, I get y equals, remember g of x means the same thing as y, negative 0 squared, which is still 0. If x is 1, I get y equals negative, in parentheses, 1 squared, which becomes negative 1. If x is 2, let's say negative 1, I get y equals the opposite of negative 1 squared. Negative 1 squared is 1, so this is still negative 1. If x is 2, I get y equals negative 2 squared like this, which becomes negative 4. If x is negative 2, I get y equals negative 2 squared, the opposite of negative 2 squared. Negative 2 squared is 4. It becomes negative 4. So basically, that's what we just talked about, okay? Watch. Remember, 1, negative 1, negative 1, negative 1. Alright, so remember we get that this blue is my parent function reflected about the x-axis. 1, negative 1, 2, negative 4. So 4 became negative 4. 1 became negative 1. 4 became negative 4. Okay? So that's a reflection about the x-axis. So when you graph this, you're basically going to do this. Okay, so watch carefully. So I'm going to graph my parent function first. So here's my parent function. 0, 0, 1, 1, 2, 4. Negative 1, 1, negative 2, 4. And I graph it. You graph your parent function first. Okay, just like this. Alright, And on the worksheet, if you have to do the transformation, then you can do this. Remember, this right here is f of x equal x squared. That's your parent function. Now what you're going to do is you're going to graph g of x, which equals negative x squared. So all you do is you take the y-coordinate and you reflect it about the x-axis. You take its opposite. So see how this y-coordinate is a positive 1? It becomes negative 1. You see how this y-coordinate here is a positive 4? Reflected about the x-axis, I get the y-coordinate negative 4. 0, 0 stays 0, 0. See how this y-coordinate's a positive 1? When reflected about the x-axis, it becomes a negative 1. Positive 4, negative 4. And so, I get this green graph. Oops. Something like this. Do the best you can. And there's the reflection. So this right here means the reflection of a parent function about the x-axis. Alright, so that's how you would graph this. So you graph the parent function, and then from those points, see how I use those points and reflect it? I have to use those 5 points. That's what you do. That's what you're going to do when you do transformations. You're going to take those 5 points from the parent function and do a reflection. Or whatever transformation it is. Previously we looked at shifting up, down. Now we're looking at reflection. Okay? So that's a reflection. So a negative out in front is a reflection about the x-axis. All right, let's look at this one. Okay, so let's talk about a horizontal shift. Now the horizontal shift is a little bit harder to comprehend. So this can be a horizontal shift. Okay. All right, now let's look at f of x equals x squared again. Okay, and let's think about this. Let's suppose I want to graph g of x, which equals x minus 1 squared. Okay, g of x, which equals x minus 1 squared. All right, I want to think about something. Okay, so remember for f of x, I used the point 0, 0, 1, 1, negative 1, 1, 2, 2, 2, 4, and negative 2, 4. Remember that? Okay, so that was for f of x. For g of x, let's see what happens. So if I use the x-coordinate 0, let's see what happens. I get wherever see the x, I plug in 0. So I get y equals 0 minus 1 squared, which is a negative 1 squared, which is 1. Okay? Alright, now let's do x equal 1. When I use x equal 1, I get y equals 1 minus 1 squared, which is 0 squared, which is 0. If I use negative 1, I get y equals negative 1 minus 1 squared, which is negative 2 squared, which is 4. If I use 2, I get y equals 2 minus 1 squared, which is 1 squared, which is 1. Okay? And negative 2, I get y equals negative 2 minus 1 squared, which is negative 3 squared, which is 9. Okay? Alright, now, let's see what happens when I graph this. Alright, so I am going to graph, let me use this again. So I'm going to graph my parent function first. Here's my parent function, okay? And then from here, I'm going to go ahead and take this off so I can read the points. Alright, so here's my parent function, right here. Okay, so that's f of x. And I want to graph, I'm going to do that in green, I want to graph f of x. I want to graph f of x, which equals x minus 1 squared. Okay, so that's what I'm going to graph. Alright, so let's see what happens. Okay, so watch what happens. So 0, 0, all right, became the point 0, 1. Okay. Well, okay. So let's just plot the points. So here's 0, 1. Okay. Here's 1, 0. Here is negative 1, 4. And then the 2, 1 is here. Yeah, 2 1's here. And then negative 2, 9. Okay. I'm using the same. All I did was I used the same x coordinates as before. All right. I just got in these cases just got different y values. Negative 2, 9. And so negative 2, 9 is way up here. Let's say negative 2, 9 right here. Okay. Now I want you to notice what happens. I'm going to take x squared again. Okay, let me trace over this. Okay, watch what's happening. Okay, I'm going to take the blue graph and I'm going to move it over to where it overlaps with these other points. Okay, watch. I'm moving it over. Oops, I moved the wrong one. Okay. All right. So let me do this. So here was the points for this. Remember that? Okay, that was this. All right. Now here was my parent function. So watch what happens when I move it over. Look, I'm moving it to the right, right? Moving to the left, to the right. So notice when I moved it to the right, see it was here. When I moved it to the right, you see the blue graph overlaps those points now? Okay, so watch again. The blue graph is x squared. That's my parent function. The green will be the function x minus 1 squared. But I want you to notice what kind of transformation this is. So when I move the blue graph to the right, notice how many units am I moving it to? I'm moving in how many units? 1 unit. And then at that point, do you see that the graph overlaps all these green points? So this right here is now the graph of this. But notice I moved it to the right. How many units? 1. If I were to shift it up 1 unit, then you'd have that plus 1 on the outside. Remember that? If I shift it down 3 units, then it would say minus 3 on the outside. But do you see how that 1's on the inside, not on the outside? So if it's on the inside, it's a horizontal shift. So going back right here, remember this was my parent function. I moved it to the right 1 unit to get this function here, and I moved to the right. Now, intuition, if you're not careful, intuition says, well, that's negative. Why am I not moving it to the left? Because it's got to be the form x minus a number. Okay, x minus a number. So this right here is positive 1, so you're moving it to the right 1 unit. So it's kind of counter-tuition here, so many students do get confused with this. Okay, so I'm going to go back right here. I am going to take this transparency, put it on top of this one, and I'm going to go ahead and just connect the dots with a green marker, just like this. Okay, and so notice that the blue graph, if I shift it to the right 1 unit, oops, wrong one. I keep doing that. So if I shift the blue graph to the right 1 unit, okay, if I take the blue graph and I shift it to the right 1 unit, I get the new graph. And the green graph, remember, is this one. Okay, so this is a horizontal shift. I went to the right. I could have gone to the left, depending on the function. Okay, all right. So here's the idea. Here's what you're going to do. The horizontal shifting is a little bit harder for students. Okay, so here's what you can do. Let's suppose you want to graph. All right, here's the directions. So graph, or use the graph of f of x equal x squared to graph g of x, which equals x plus 2 squared. Okay, x plus 2 squared. Okay, so make sure you understand that this is a horizontal shift because the 2 is on the inside. 2 is on the inside. If it's on the outside, it would be a vertical shift. It's on the inside. Okay, so what's being squared is not just x, but x plus 2. So that's a horizontal shift. So if you recognize this is a horizontal shift. All right, so horizontal shift. And the horizontal shifts are counterintuitive. So you see how this is a plus 2? So you would think 2 to the right. It's actually counterintuitive. So it's a horizontal shift 2 units to the left. Okay? So all the points will be shifted 2 units to the left. So on the graph, on the coordinate plane, this is what you're going to do. You're going to do this in the coordinate plane. You're going to graph the, and sometimes it helps if you use different colors, but you're going to graph the quadratic function first, the parent function first. So 0, 0. Let me use blue. So 0, 0, 1, 1, 2, 4. Negative 1, 1, negative 2, 4. Okay, it looks like this. Okay, and then I want to graph, so this right here is f of x equal x squared, your parent function. Now you want to graph g of x, which equals x plus 2 squared. Alright, so remember, x plus 2 squared, that's a horizontal shift, so I'm going to go to the left. It's counterintuitive. You go to the horizontal shifts are counterintuitive. You go to the left 2 units. So when I graph it, this is what it means. So every point, see those 5 points, you're moving it to the left. So 0, 0 becomes this. 1, 1 becomes this. This point here becomes this point here. This point, 2 units to the left, becomes this point. This point becomes this point. So notice I took every point on the blue graph and I shifted it 2 units to the left. Okay? And so you get this. That's what you get. Alright, now, here's what I want you to notice. I need for you to understand this. So if I can find that transparency. So here's my quadratic function, my parent function, okay? If I move it 2 units to the left, see what's happening? I now get the green function. I get the new function. So I'm taking my parent function, I'm doing a horizontal transformation 2 units to the left, and I get this. Okay? So 1, 2. So every point, notice every point's moving 2 units. Here's 1 unit, here's the second unit. Okay? Alright. So use something like this to help you if you can get a hold of cheap transparency, just to get you through this section. But on the worksheet, this is what you're going to show. You're going to show the parent function and then the transformation. So all we've done so far was do one transformation. Alright, so all we've done so far was talked about one transformation. Here's what I mean by that. I grab the parent function. This is what kind of transformation? When you go up or down, it's a vertical transformation. You see how the number's on the outside? Okay, we talked about that kind of transformation. We only did one transformation. Then we talked about a reflection about the x-axis. So that's the other transformation we talked about. Then we talked about, if I can find it, the horizontal transformation, which is this one. Okay, so we moved it 2 units to the left. All right, so that's what you're going to show on a worksheet. You're going to show the parent function and all the transformations. We've only done one so far. Now what we're going to do next is this. So listen carefully. So what I'm going to do now is this. So here's the directions. Directions will say, use a graph of use a graph of f of x equal x squared to graph g of x which equals, and let's say it's x plus 3 squared and plus 4. Alright, so now notice I'm dealing with two transformations. So I have a horizontal transformation and a vertical transformation. Okay? Alright, now the order in which you need to do things is this. Here's the order in which you have to do things. You have to do the vertical shifting first. So vertical shifting, always do the vertical shifting first. So here's the order. Now remember, we're not doing anything with stretching or shrinking. So I'm going to skip that part. So you can do vertical shifting first, then you can do reflection about the x-axis, and then the last thing you're going to do is the horizontal shift. Okay, always do that last. Okay, always do that last. All right, now notice the question. Is there going to be a reflection about the x-axis here? The answer is no, because there's no negative in front. Okay, so all you're going to have is a vertical shift and a what? Horizontal shift. All right, now remember, the horizontal shift is the one that's counterintuitive. Counterintuitive. Okay, so if you see that plus 3, you got to think, well, I'm not going to move it to the right 3. I'm going to move it to the left 3. Okay, but that's going to be the last thing you're going to do. All right, so here's how you're going to do this on graph paper. So listen carefully to this. First thing you're going to do is you're going to graph the parent function. So step 1, graph the parent function. Step 1, graph x squared. Okay. Then step 2, you're going to do the vertical shift. So graph x squared plus 4. So that means you can take the parent function, you can shift it up 4 units. So shift up 4 units. So in other words, shift x squared up 4 units. That's what that means. Take your parent function and shift it up 4 units. All right, now we're going to take care of the horizontal shift. So step 3 is to graph x plus 3 squared plus 4. And you're going to do that by taking step 2, taking the graph from step 2. So take the graph from step 2. And shift to the left. Remember, counterintuitive, so it's left 3 units. All right, so basically you're going to graph the parent function first. Then you're going to take the parent function. You're going to take the parent function, and you're going to shift it up 4 units. You're going to take that graph that you just shifted up 4 units. You're going to take that, and you're going to move it to the left 3 units. So that's going to be what you eventually graph. That final graph is this. Okay, so watch what happens. All right, so you're going to do the x squared first, your parent function. So that's going to be the blue one. 0, 0, 1, 1, 2, 4. Negative 1, 1, negative 2, 4. Okay, so it looks like this. Just like that. Okay, now let's use a different color. All right, now the next thing I'm going to do, the next thing it says is I got to do the vertical shift. So I'm going to go up 4 units. So I take every point and go up 4 units. So just count. That's all you do is just count the grid lines. Okay, 0, 0, move it up 4 units. 1, 2, 3, 4. Just like this. 1, 1, move it up 4 units. 1, 2, 3, 4. Take this point, move it up 4 units. 1, 2, 3, 4. Take this point, move it up 4 units. 1, 2, 3, 4. 1, 2, 3, 4. Okay, and then you just draw your graph right here. And just know, now I didn't draw it very well here, just know that this is x squared plus 4. This is x squared. Okay? Alright, and then finally I'm going to take that green graph and I'm going to move it to the left. And what was it? Left 3 units? And move it to the left 3 units. So that's going to be the red graph. Okay, so watch. Move every point to the left. 1, 2, 3. 1, 2, 3. 1, 2, 3. 1, 2, 3. 1, 2, 3. And the red graph is your final graph. So this is the graph that you wanted. So this is, what was it called? It was called g of x equal x plus 3 squared plus 4. So this is g of x. G of x equal x plus 3 squared plus 4. Okay, so notice the transformations. So you're going to have two transformations here. You're going to take the parent function, you're going to move it up 4 units, and then to the left 3. Okay, so that's what you have to show. You have to show those three things. And then your final graph is the graph of what you want. All right, okay, let's look at this one. Okay, so suppose you want a graph. Okay, so use the graph of f of x, which equals x squared, to graph g of x, which equals, let's say this time it is this. Okay, let's say that's it. All right. Okay, so let's think about, now remember the order. You do the vertical shifting first, you do the reflecting next, and then the horizontal shifting. Always do the horizontal shifting last. Now we're not dealing with stretching or shrinking in this lesson. So that's the only three I'm going to list. Okay, so remember the first thing you're going to do is you're going to graph the parent function. So step 1 is to graph the parent function. So graph x squared. Okay, step 2. All right, so notice there is a reflection. So you see that negative. So step 2 is to reflect x squared about the x-axis. Okay, step 3. So notice that see this right here? So you got to think, okay, it's inside the parentheses, so it's not outside. If it was outside, it will be a vertical shift. So this is a horizontal shift. So that's a horizontal shift. So take the graph from step 2. So you take the graph from step 2. From step 2. And shift horizontally to the, now it's counterintuitive. See how it says you think of this as negative 2? So you don't move it to the left 2 units, you're going to move it to the right 2 units. So to the right 2 units. Okay? Alright, so let's see what you're going to do. So here's what you do. You're going to take, you're going to graph x squared first. So you graph x squared first. Okay, just like this. You can graph your parent function. 0, 0, 1, 1, 2, 4. Negative 1, 1, negative 2, 4. Okay, just like that. Just like that. So that is x squared. Now, remember step 2, this you have to do the reflection. So basically you can take those 5 points and you reflect it about the x-axis. So that's going to be the green one. So you're going to take 1, 1 becomes 1, negative 1. 2, 4 becomes 2, negative 4. 0, 0 stays 0, 0. Negative 1, 1 becomes negative 1, negative 1. And negative 2, 4 becomes negative 2, negative 4. And so you just do this and do the best you can. Okay, and there's this right here is going to be x squared, negative x squared. So that's a reflection about the x-axis. And then finally, the next thing you got to do is that horizontal shift. So you see how it's horizontal shift to the left, to the right 2 units. So you go to the right 2 units. So this is going to be the blue end. So all those 5 points, you're going to shift to the right 2 units. So 0, 0 becomes 2, 0. 1, negative 1 becomes 3, negative 1. Negative 1, negative 1 becomes 1, negative 1. 2, negative 4 becomes, shifted 2 units, becomes 4, negative 4. And then at this point, shift 2 units, becomes this. And so, oops, I did not need to use blue again. Sorry. So then the red will be the final graph you want. And that's all you do. So this is going to be the final graph you want, so label it. You're going to say this is g of x, which equals negative x minus 2 squared. Alright, so notice a transformation. Okay, so any question at this point? And that's all you do. That's all you do. That's all you're going to do. So we spent almost an hour on the basic idea of transformations using x squared. Now the next one we're going to do will be absolute value. So it'll be a little bit quicker because it's the same idea. So we won't be talking about, see how I use transparency to kind of initiate the discussion about shifting horizontally and vertically and reflection. We're going to skip that part because it's always going to be the same regardless of the parent function. Alright, so the basic stuff will be the same. Okay, so this is what you show in the worksheet. You show three things: the parent function, and then the transformations, and then you're gonna label the final graph, just like we did. Okay, so that takes care of this part of the lesson.